And I want to go for W cross W. Maybe that one, and we'll conclude with this idea. I, J, K again. So we're going to always pick I, J, K. List W and list it again. W is right there. That is 3, negative 2, negative 1. And 3, negative 2, negative 1. That would be the I component. That would be 2 minus 2. If I move for the J component, that would be negative 3 minus 3. And if I run for the K component, that would be a negative 6 minus 6. And you notice we get 0, 0, 0, or the 0 vector. That's not a coincidence. That happens all the time. Now we want to look at slightly different problem. Now graphically. V cross W, assume the angle between those is less than 180 degrees. If I take vector V, and if I take vector W, the cross product oh boy, I hate it when that happens. The cross product would be a vector that is perpendicular to both, and if I extend those two, and the magnitude, of course this is the angle between them, the magnitude of the cross product turns out to equal the area of the parallelogram that's enclosed by them. And in calculus, when they say, hey, given two vectors, can you find the area? Oh, come on. Can you find the area of the triangle that they enclose? You only take half of this distance. And that's how it works. So, let me look at a couple of problems. Now here we say the direction of the cross product. That's something you could read. We're not going to really spend time on it because there is no homework on it. Cross your fingers and point. But here, the magnitude of the cross product is equal to the area of the parallelogram that the two vectors enclose. I would like to look at a few problems. On 42, they say, find a vector orthogonal to U and V. Here's U, and here's V. And what do we know? If we cross any two vectors, the vector, the cross product, is perpendicular to both. So in this case, if we want to find a vector that's perpendicular to both, well, let's take U and cross it with V, W, not V. And that would be I, J, K. U is 2, negative 3, 1, and W is 1, 1, 3. And that would be, in the I component, if I cross that down, that would be those two. negative 9 minus 1. In the j component, minus 6 minus 1. And in the k component, that would simply be 2 plus 3. So I am getting a negative 10, a negative 5, and a 5. And there it is. Now, we could check our work. We want it to be orthogonal to both. Well, let's see. If we take u and dot it with u cross w, should we get a 0 if these are orthogonal? U is 2, negative 3, 1. And u cross w is negative 10, negative 5, and a 5. And if I dot those, that's negative 20 plus 15 plus 5, and that is negative 20 plus 20, which is 0. Not only that, I'm going to also take v and dot it with u cross w. I'm sorry, I keep saying I'm stuck in the w. So w is 1, 1, 3. Dot it with negative 10, negative 5, 5. And that would be a negative 10 minus 5 plus 15. And that would be negative 15 plus 15, which is a 0. And that's guaranteed. You know, and why would I lie? Last problem in this section I want to look at would be problem number 48. It says find the area of parallelogram with one corner being P1 adjacent to those two sides. Now the reason they're telling you that, one thing you want to do, normally you could do this any way you want, but remember, you want the two vectors to share a common vertex. Otherwise, the cross product wouldn't work like we said. So, if you fix P, you really want this to be P, this P2, and this P3. Of course, you could do this in any order. So, well, this is the idea. If we find P1, P2, and P1, P3, and we cross the two, we're going to get this vector, and the magnitude of that will give us the area of the parallelogram. So, if I go for P1, P2, that would be, and let me see how that works. 2 minus 2, that's a 4. 1 minus 0 is 1, and negative 1 minus 2 is negative 3. And P1, P3, that's a 4, and that's a negative 1, and that's a 2 minus a 2, that's a 0. And if I take P1, P2, cross P1, P3, well, what a coincidence. I'll just kind of put the lines right there and say, okay, the I is going to be 0 minus 3. The J will be a negative 0 minus a negative 12. And the K component will simply be a negative 4 minus 4. So I'm getting this to be a negative 3, a negative 12, and a negative 8. And if I find the magnitude of P1, P2 crossed with P1, P3, that would be the square root of negative 3 squared plus a negative 12 squared plus a negative 8 squared. That would be the square root of 9 plus 144 plus 64. What is that? 64. That would be the square root of 217, which is the area of this parallelogram that it encloses. And if they want the area of the triangle that the two vectors enclose, you just take half of that. There's the homework listed with this section, and that concludes this section and this chapter.